Good evening, all the GW soldiers. How is everyone doing? I hope all of you are doing really well and you guys are preparing really well for your GATE 2023. Now, as you know, we started revision through question series where in each session we are revising an entire subject, and that too by solving problems. See, this is the most effective way of revising any subject. If you want to revise, then you must revise through solving questions, because when you are solving problems, let's say you are able to solve problems of a topic, that means that you don't need to revise that topic anymore. But if you are not able to solve the topic, then you go and watch the lectures or read the notes or whatever. So this is the best way of revision. And today in this session, we are going to revise strength of materials. And this session is beneficial for all the students preparing for GATE ME, GATE XE, CE, PI, chemical, aeronautical, whichever branch has a strength of materials. If you want to revise strength of materials, then this is the session for you. Now, without any further ado, let's move on. And before starting the questions, I have a very big and very important announcement for you. You have an opportunity to write GATE before GATE. Yes. So beta, this is the last session that we will be having for all our GW soldiers preparing for GATE 2023. We are bringing an entire mock GATE test of 65 questions live on YouTube. Yes, you heard me right. This session will be live on YouTube, where the entire team Drona will be solving the exact GATE pattern tests with you guys. So there will be 65 questions and the test will start at 2:30 p.m. on 31st of January. Yani ki, that means it will be in the slot of mechanical engineering. So all the mechanical students, you guys are welcome to attend this lecture, which will be live on YouTube on 31st of January, 2:30 p.m. The entire team Drona will be solving 65 questions. And let me tell you the motive behind this mock test. The objective of this mock test is to one last time prepare you guys before writing your GATE. So this is GATE before GATE, so that you will have that feel, and we all members want to be with you for that experience. Okay, so beta, the entire team Drona will be discussing the solution of these 65 questions with you guys, and you will feel motivated and confident after this. So beta, the objective behind this is not to give you very difficult questions and demotivate you. The objective behind this mock test is to increase your confidence, boost your confidence. Okay, so beta, don't forget to be live on 2:30 p.m. on 31st of January with Team Durga. So I will see you on that day at this time. Okay, chalo. So beta, let's begin our first question, and our first question is an MCQ question, and this question is of 1 mark. It's an MCQ question and it is of 1 mark. Read the question and answer it very carefully. I have easy to moderate and then difficult questions. Okay, so initially you will have these easy to moderate questions, and then we'll pick up the difficulty level. A body subjected to which one of these loads does not undergo change in volume? Give me the answer quickly. A body subjected to which one of these loads does not undergo change in volume? Okay. So we have got our first answer. The answer to this question will be uniform tension. No, if there is tension, volume is going to change. Pure shear, pure bending, or hydrostatic pressure. So the answer to this question is hydrostatic pressure. D? Nobody. No. See, in case of uniform tension, length is going to change, diameter is going to decrease, and there will be change in volume, right? In case of hydrostatic pressure also, the volume is going to decrease, right? Hydrostatic pressure means you are applying compressive force from all sides. So if it is rubber, then the volume is not going to change. But for all the other materials, the volume is going to change. In case of pure bending also, if I bend a beam, then the length is going to increase or decrease depending upon the fiber. But in case of pure shear, there will be no change in volume. Beta, what is the formula for change in volume? What is the volumetric strain formula? It is 1 minus 2 nu by E sigma x plus sigma y plus sigma z, right? And for pure shear, sigma x will be 0, sigma y will be 0, sigma z will be 0, right? In case of pure shear, normal stresses will be 0. So epsilon v is going to be 0. Yes. So in order to have change in volume, you need to have sigma x, sigma y, sigma z, at least one of these normal stresses, right? So in case of pure shear, you don't have any normal stress, so there will be no change in volume. I hope you guys liked this question. Although it is of 1 mark, but it is a very conceptual problem, right? If your concepts are clear, then only you will get the right answer. Otherwise, you will get confused between hydrostatic pressure and pure shear. Okay, chalo. So let's move on to the next question, shall we? Okay. So this is our next question, and this is an MCQ problem again of 2 marks. Read the question. A point in a body is subjected to plane state of stress in XY plane. Sigma x is 140 megapascal, sigma y is 60 megapascal, and the major principal stress is 150 megapascal. Magnitude of the in plane shear stress tau xy is. So they have given you sigma x, they have given you sigma y, and they have given you the major principal stress, the maximum principal stress, and they are asking you what is tau xy. So how are you going to find the value of tau xy? You have sigma x, you have sigma y, and you need tau xy. See, you have two options to solve this problem. Either you apply the formula of the principal stress, and this is the maximum principal stress, so it is going to be sigma x plus sigma y by 2 plus sigma x minus sigma y by 2, root over sigma x minus sigma y by 2 whole square plus tau xy square. Otherwise, I have a better option for you. You can use these two equations of principal stresses. I hope you guys remember these equations. The first one is sigma 1 plus sigma 2 equal to sigma x plus sigma y, right? The sum of principal stresses is equal to sum of normal stresses, and sigma 1 into sigma 2 equal to sigma x into sigma y minus tau xy square. The product of principal stresses is equal to the determinant of stress tensor, right? Now, the major principal stress is 150 megapascal, and you have sigma x and sigma y. What is sigma x? 140. What is sigma y? 60, right? So what will be the value of sigma 2 from this? It will be 50 megapascal, right? It is going to be 50 megapascal. Now once you get sigma 2, you can put it here. So it will be 150 multiplied by 50 equals to 140 multiplied by 60 minus tau xy square. Now this is very easy to solve, and you will get the value of tau xy. So 150 into 50 minus 140 into 60 and root over the answer. Oh. We have a problem here. Okay. Sorry. I did it the other way around. 140 into 60 minus 150 into 50. So it is going to be root over 900 megapascal, means plus minus 30 megapascal. It can be plus 30 megapascal or it can be minus 30 megapascal. So the answer to this question is again B. Yes, just like the last question, the answer to this question is also B, 30 megapascal. So I hope you liked my solution. You can also solve this by applying the equation of principal stress. Sigma 1 will be equal to sigma x plus sigma y by 2 plus root over sigma x minus sigma y by 2 whole square plus tau x y square. But I find this solution easier to calculate, right? Using this solution, it will be easier to calculate. The calculation will be easier in this case. Chalo. So let's move on to the next question. Okay. So this is an MCQ question of 1 mark. So we are solving easy to moderate questions initially, and then slowly we are going to increase the level of difficulty. So read the question carefully. The critical load of buckling according to Euler's theory for a 4-meter long slender steel rod of uniform cross section fixed at both ends is 2 kilonewton. Critical load for a 2-meter long steel rod of the same cross section hinged at both ends will be. So in one case it is fixed at both ends, and in the other case it is hinged at both ends. When it is hinged at both ends, effective length is equal to L. But when it is fixed at both ends, then in that case, what is the value of LE? 0.5 L. When it is fixed at both ends, LE is 0.5 L. Now I can write it like this. P critical is inversely proportional to LE square, right? So can I write it like this? P2 by P1 equals to LE1 by LE2 whole square, right? Now in the first case, the P critical is 2 kilonewton, right? And in the first case, effective length will be 0.5 L and the length is 4 meter. So 0.5 into 4 meter. In the second case, it is hinged at both ends. So effective length will be equal to L and the value of L is 2. So what will be P critical in the second case? It will remain same, right? 4 into 0.5 will be 2. So it will remain same, 2 kilonewton. Are you getting this answer? Are you getting this answer? 2 kilonewton? Yes, very good, very good, very good, very good, very good. So although we are changing the end conditions, but the length is also changing, right? That is why your P critical is same. So a lot of people make mistake in this question. What they do is they keep the length same. See, we are changing the end conditions and we are also changing the length from 4 meter to 2 meter. Okay, so the effective length remains same in both cases. In the first case, length is 4 meter and it is fixed at both ends. So effective length is 0.5 into 4, 2 meter. In second case, length is 2 meters and it is hinged at both ends. So effective length again will be equal to L, means 2 meter. So effective length is not changing. So P is also not changing. Yes? Okay. Thank you so much, buddy. Thank you so much for the appreciation. Chaliye, let's move on to the next question. And this next question is an MSQ question. Yes. And of 2 marks. So let's read the question carefully. The state of stress at a point in a body is shown in figure. Which one or more of the following statements is or are correct regarding the above state of, not above, below state of stress? Okay. So you have this state of stress. You have sigma x 160, sigma y is 0, and you have tau xy. According to our sign convention, it is going to be minus 60. And then you also have an oblique plane. Okay. Now, one by one, we will check which one of these statements are correct. The first statement is center of the Mohr circle is at 160 and 0. So what are the coordinates of center? What are the coordinates of center? Center of Mohr circle is at sigma x plus sigma y by 2 and 0, right? And here sigma x is what? 160. Sigma y is 0. So the center of this Mohr circle is going to be at 80 and 0. That means the first statement is absolutely wrong. Yes, the first statement is absolutely wrong. Second statement is radius of Mohr circle is 100 megapascal. So let's check it out. Radius of Mohr circle is 100 megapascal. So what is the formula of the radius? Radius of Mohr circle is given by root over sigma x minus sigma y by 2 whole square plus tau xy square. So what is sigma x? Sigma x is 160. What is sigma y? It is 0. And what is tau xy? According to our sign convention, it should be minus 60, but it doesn't matter because it is square. So 80 square plus 60 square. What will be the answer? 100? Yes. So the radius is 100 megapascal. So the second statement, the B statement, is absolutely right. This statement is absolutely right. Now the third statement, maximum principal stress is 200 megapascal. Now as you have the radius and the center, it is very easy to find out the maximum principal stress, right? What will be sigma maximum? Both are positive, so it will be center plus radius. Both are positive, right? So it will be center plus radius. So center is at 80 megapascal and radius is 100. So sigma maximum is going to be 180 megapascal. Sigma maximum is 180 megapascal. That means this statement is completely wrong. Yes, the third statement is also wrong. Now the fourth statement is magnitude of shear stress on plane AB is 80 megapascal. Magnitude of shear stress on plane AB is 80 megapascal. Now according to our sign convention, we calculate theta from vertical and clockwise theta is positive for us, right? Sorry, negative for us. So our theta will be minus 45. So magnitude of shear stress on plane AB is 80 megapascal. Let's calculate tau on plane AB. So tau at any angle theta is minus of sigma x minus sigma y by 2 whole square plus, sorry, not whole square, sine 2 theta plus tau xy cos 2 theta. So tau on plane AB will be equal to, this will be minus 160 by 2 sine of minus 90 minus 60 cos of minus 90. Now cos minus 90 will be 0 and sine minus 90 will be minus 1. So this will be equal to 80 megapascal. That means the last statement is absolutely correct. So there are two statements that are correct here, B and D. I hope all of you are getting the correct answer. Yes. Okay. So shall we move on to the next question? Let's move on to the next question. A thin-walled cylindrical pressure vessel of internal diameter 2 meter is designed to withstand an internal pressure of 500 kilopascal. If the allowable normal stress at any point within the cylindrical portion of the vessel is 200 megapascal, the minimum thickness of the plate of the vessel is. So this is an NAT question and it is of 1 mark. very simple problem. You have a thin cylindrical pressure vessel where you have the value of sigma maximum. It can maximum go up to 200 megapascal. Now you have the diameter, you have the pressure, you need the thickness. So what is sigma maximum for a cylindrical pressure vessel? For a cylindrical pressure vessel, sigma maximum is PD by 2T. For spherical vessel, it is PD by 4T, right? Now sigma maximum is 200 megapascal. Pressure is 500 kilopascal, means 0.5 megapascal, and diameter is 2 meter, means 2000 mm. And you need thickness. So it is going to be 400 by 400, sorry, 1000 by 400 means 5 mm. So the answer to this question is 5 mm. 50 or 5? I think it is going to be 5, right? 0.5 into 2000 will be 1000 divided by 400. So it is going to be 5. Angle should be minus 50. Beta, this was 45 degree, not 40 degree, okay? The angle was 45 degree, not 40 degree. Okay. So the answer to this question is 5 mm, a very simple question. Let's move on to the next question, and this next one is an NAT question, and that too of 2 marks. Okay, let's solve this one. The figure shows two identical massless beams AB and CD clamped at one of their ends. Left end of the beam CD rests on the right end of the beam AB such that the ends of the beams are just in contact. Beams are unstressed before the application of load. Assuming no friction at the contact, now if a uniformly distributed load of 100 Newton per meter is applied on beam CD, the bending moment at B of the beam AB is. So we have to find out answer 2.5 mm. How your answer is 2.5 mm, beta? Diameter is 2 meter. So it is going to be 0.5 into 2000 divided by 200 into 2. Okay, 2.5. 2.5. So sorry, my bad, my calculation mistake. 2.5 mm. Okay, chalo. So after rectifying the last question, let's move on to this one. So here we have two cantilever beams connected together at point A and C. We have to find the maximum bending moment at point B. So what we are going to do? We are going to separate these two beams, right? We are going to separate these two beams. So there will be one beam like this and another one like this. Both are cantilever beam of same length. Now, in order to calculate the bending moment in this beam, I need the load, right, acting at point C. See, this is CD, this is AB. So in order to find the maximum bending moment, I need the force here. Now, you can see that point C is going to apply a downward force on point A. And in return, point A is going to apply equal and opposite force at point C. Let me call this point W. Sorry, let me call this load W. Okay, this load is given 800 Newton per meter. Now both beams have the same flexural rigidity. Now I need the value of this W, then only I will be able to calculate the bending moment at point B. So how we are going to find the value of W? By applying the compatibility equation. The deflection at point C should be equal to the deflection at point A. See, C and A are in contact with each other. If A moves down by 1 mm, C will also move down by 1 mm. So the deflection at these 2 points must be same. Now what will be the deflection at point C? Due to 800 Newton per meter, it will have a downward deflection. How much? WL to the power 4 by 8 EI. I will put the values in Newton and meter. So W L to the power 4 by 8 EI minus, due to this W, it is going to be WL cube by 3 EI equal to, at point A, there will be only downward deflection due to this W. So W1 cube by 3 EI. Now all the EIs are going to be cancelled. This will become 100 equal to 2W by 3. So W will be equals to 300 by 2 means 150 Newton, right? So I have got the value of W, 150 Newton. Now once you get the value of W, you can find the bending moment at point B. So bending moment at point B will be 150 into 1 means 150 Newton meter. Yes, 150 Newton meter. It should be Newton meter, not Newton per meter. This is wrong. It is 150 Newton meter. Yes? Are you getting this answer? Everyone is getting this answer? 150 Newton meter? I hope so. Please confirm. Okay. Let's move on. And let's move on to the next question. Now this next question is another NAT type question for 1 mark. If the two principal strains at a point are 400 into 10 to the power minus 6 and minus 200 into 10 to the power minus 6, maximum shear strain is, what is going to be the maximum shear strain? You have the two principal strains, 400 into 10 to the power minus 6 and so gamma maximum will be 400 into 10 to the power minus 6 minus of 200 into 10 to the power minus 6. So it is going to be 600 into 10 to the power minus 6. Yes. Now please don't divide it by 2. That will be the formula of tau maximum, sigma 1 minus sigma 2 by 2. But in case of gamma maximum, it is only epsilon 1 minus epsilon 2, not divided by 2. Yes? Chalo. Let's move on to the next question, and this one is interesting. This is an MCQ question and of 2 marks. For the beam shown in figure, find reaction at B. Assume flexural rigidity equal to EI. So you have a continuous beam. It is roller supported at A and B and it is hinged at C and it is subjected to a UDLW over the entire length. And they are asking you what will be the reaction at point B. So how are we going to solve this one? Let's remove the support at point B. Let's say there is no support at point B. So when I remove the support at point B, I will apply a reaction. let's say this is RB. Now, in order to find RB, I will apply compatibility equation. And what will be my compatibility equation? I know that at point B, deflection must be equal to 0. Why? Because at point B, you have a roller support. So, vertical deflection at B must be 0. And vertical deflection at B will be W 5W L to the power 4 by 384 EI. Due to the UDL, it will be downward, and due to RB, it will be upward. Let me consider it negative. Minus RB L cube by 48 EI, and this must be equal to 0. So from here, what will be the value of RB? It will be 5WL by 8. Yes? Everyone is getting this answer? 5WL by 8. So the answer to this question will be A. Yes? 5WL by 8. So shall we move on? Let's move on. So this is another MSQ question, and this is for 2 marks. Let's solve this one. What is the question? Consider the shear force diagram shown in figure. Assuming there is no couple acting on the beam, which one or more of the following statements is or are correct? So we have a shear force diagram, and we have to assume that there is no couple acting anywhere on the beam. And these are the statements. Which one of these statements are correct? The first statement is load acting at point B is 2200 Newton. Second is bending moment at A is 2400 Newton meter. Third is maximum bending moment is at D. And last is there is no point of contraflexure on the beam. Okay. So which one of these statements is correct? So first statement, let's check whether it is correct or not. So the first statement is load acting at B is 2200 Newton. So point B is here. Okay. Now, the shear force at point B is changing from minus 1200 Newton to 1000 Newton. So how much it is changing? It is changing from minus 1200 to 1000. So total change is 2200 Newton. So the force at point B will be 2200 Newton, right? And at any point, the change in shear force is going to be the load, right? At point A, what is the change? Minus 800 to plus 800. So the load at A will be 1600. At point C, what is the change? Minus 800 to 0. So the load here will be 800 Newton. At point E, what is the change? 0 to 1000. So the load at E will be 1000 Newton, right? So at point B, minus 1200 to 1000, the total change is 2200 Newton. So this first statement is absolutely correct. What is the second statement? Bending moment at A is 2400 Newton meter. Now, we know that MC minus, sorry, MA minus MC is going to be equal to this area. Area of the bending shear force diagram. How much is it? 800 into 3. Although it is negative, but it doesn't matter. We need the magnitude only. Now we know that as there is no couple, the moment at point C and point E must be equal to 0, right? If there is no couple, the moment, bending moment at the ends will always be 0. So MA will be equal to 2400 Newton meter. MA is 2400 Newton meter. So this second statement is also true. Maximum bending moment is at D. So shall we find out whether it is true or not? Let's find out. So we have the moment at A, 2400 Newton meter. Moment at point D will be equal to how much? So if I calculate moment at point D, it will be equal to this area minus this area, right? And sorry, this area plus this area, and this area is negative. So 800 into 5 minus 800 into 3. So it will be 4000 minus 2400 means 1600 Newton meter. So beta, maximum bending moment is not at D, right? Because bending moment at A is greater than bending moment at D. So how can this be maximum? So this statement is also incorrect. There is no point of contraflexure on the beam. Will there be a point of contraflexure? Of course there will be a point of contraflexure. Why? Shear force is changing sign 3 times. Shear force is changing sign 3 times. So bending moment will change sign 2 times. How do I know? Because bending moment at A will be negative. Okay, bending moment at A will be negative, C. And bending moment at D is positive. So negative to positive. Shear bending moment is changing sign, right? Shear force is changing sign 3 times. So bending moment is going to change sign 2 times. Okay. One, it will change sign somewhere here. Another time it will change sign somewhere here. So beta, it is going to change sign 2 times. So there will be 2 points of contraflexure. So this statement is incorrect. So C and D are not correct. A and B are correct. I hope everyone is getting the answer. I hope everyone is getting the answer. Right? A and B are correct. C and D are not correct. Okay? Chalo. Let's move on to the next question. And this next question is an MCQ question for 2 marks. What is the question? Cantilever beam AC is composed of 2 segments AB and BC that are rigidly connected at B. Flexural rigidity of the segment AB is EI. Flexural rigidity of BC is assumed to be infinite. BC is rigid. Determine magnitude of slope at B due to a force applied at C. We need to find the magnitude of slope at point B. So in order to find the magnitude of slope at point B, what we are going to do? See, if you draw the elastic curve for this beam, it is going to bend from A to B, but from B to C it will remain straight, right? From B to C it will remain straight. Okay. Although it doesn't matter, right? Why am I doing this? It doesn't matter. If you want the slope at point B, just move this load from here to here, right? Just move this load from here to here. So if I move the load from C to B, I will get a force P and a couple P into L. Now calculate the slope at point B. So the slope at point B will be due to the force as well as the couple. So due to the force, it will be WL square by 2EI. So PL square by 2EI. And due to the couple, it will be ML by EI. So M is PL into L by EI. So what will be the slope at point B? It will be 3PL cube, sorry, PL square by 2EI. So the answer will be 3PL square by 2EI, D. Now, even if they ask you the slope at point C, the answer will remain same. Even if they ask you what is the magnitude of slope at C, your answer will remain same. Why? Because from B to C, the beam is rigid. So from B to C, it is not going to bend. From B to C, the elastic curve will remain straight. So whatever slope you are going to get at point B, it will remain same up to point C. From point B to point C, the slope is going to remain same. So theta C is also going to be equal to theta B. Chalo, let's move on to the next question. Now the next question is an NAT question, and this question is for 2 marks. Let's solve this one. A solid steel shaft of 80 mm diameter is rotating at 1000 rpm and transmitting power. It is subjected to torsion only. A strain gauge mounted on the surface of shaft with its axis at 45 degree to shaft axis gives the strain reading as 4 into 10 to the power minus 4. E is 200 gigapascal, Poisson's ratio is 0.3, power transmitted by the shaft is. In order to find power transfer, we need the RPM and we need the torque. So we have the RPM, but we don't have torque, but we have the strain reading at 45 degree to the shaft. So let's say this is our shaft, which is subjected to torsion. And we have mounted a strain gauge at 45 degree. Okay. So at 45 degree, we are getting the strain reading 4 into 10 to the power minus 4. If you remember the Mohr circle, of a shaft subjected to only torsion means pure shear, this is the Mohr circle, right? This is the vertical plane, this is the vertical plane, this is the horizontal plane. These two planes are at 45 degree, right? This is at theta equals to 45 degree. This is at theta equals to minus 45 degree. Okay, these two planes. And on these two planes, what is the normal strain? What is the normal stress? On these two planes, the normal stress is equal to tau. Whatever tau you are going to get, the normal stress will be same. So at 45 degree, you calculate sigma, okay, and you will get your value of tau. Okay, it will be equal to tau. So at 45 degree, we have the value of epsilon, right? Epsilon at theta equals to 45 degree is how much? 4 into 10 to the power minus 4. So sigma at theta equals to 45 degree is going to be equal to E into theta equals to 45 degree. So sigma at theta equals to 45 degree will be equal to how much? 200 into 10 to the power 3 into 4 into 10 to the power minus 4, right? So sigma at theta equals to 45 degree will be equal to how much? 80 megapascal. Means tau will be equal to 80 megapascal, because under pure shear, sigma at theta equals to 45 degree is tau only. Here you get tau, here you get tau, here you get tau, here you get tau, right? Plus tau minus tau. But at all these 4 points, the stress is equal to tau only. So if I get sigma here, it is equal to tau, 80 megapascal. Now once you get tau, you can calculate the value of T. Tau will be equals to 16 T by pi d cube. So 80 will be equals to 16 T by pi into, what is the diameter? What is the diameter of the shaft? 80 mm. So you are going to get the torque. It is 8042,477 point something Newton mm, means 8042.477 Newton meter. Now once you get T, you can calculate the power. RPM is 1000, right? So power P will be equal to how much? 2 pi nt by 60. So 2 pi into 1000 into torque is 8042.477 divided by 60. So power will be equal to 842206.22 watt, or I can write 84.22, sorry, 842.20 kilowatt, right? 842.2 kilowatt. The answer will be 842.2 kilowatt. I hope everyone is getting this. Okay. So with this, we end this session. But before leaving, I would like to remind you again that you have an opportunity to write gate before gate with the entire team Drona. Let me tell you about this session. It is going to be a mock gate. It will consist of 65 questions exactly on the pattern of gate. But this test is going to be conducted live on YouTube. And that too with the entire team of Team Drona. So you have this opportunity to write your mock gate with us, with the entire team Drona. Negi sir will be there, I will be there, Vishwajit sir will be there, Swadesh sir will be there, Aditya Pal sir, Vinay sir, Ramanand sir, Sandeep sir, Vishal sir, everyone is going to be there. The entire team Drona is going to be there, where we are going to solve the entire mechanical engineering mock gate with you guys, and the test will be conducted on 31st of January exactly at 2:30 p.m. and live. Okay, where on Unacademy, sorry, on Physics Wallah Gate MEPICE channel, MEXCE channel, on Physics Wallah Gate MEXCE channel. Okay, so you all are invited for this live test, which will be conducted on 31st of January at 2:30 p.m. So I'll see you soon. Till then, bye bye. Take care.